this topic is about finding the vertex of a quadratic function by completing the square. It is also about finding solutions of a quadratic equation by completing the square. Feel free to pause as I go through the concepts and some examples. So normally you're used to seeing a quadratic equation take the form y is equal to ax squared plus bx plus c, where a, b, c are real numbers and a cannot be equal to 0 because we need the x squared term to be present in order for it to be quadratic. But this is also the same thing as expressing the quadratic in completing the square format, which is a, capital A, a different a to the a there possibly, x plus p squared plus q, where in this case a, p and q are elements of reals, again real numbers, but again a is not allowed to be 0 because if a is 0 then the x squared term is not present. So we want to be able to move from the, I call the left hand side the expanded form of the quadratic equation to the completing the square format of the quadratic equation. So we want to be able to move freely from left hand side to right hand side, because in different situations it might be useful to have it in either form. Okay, so that's the aim of completing the square, so to get into different form. So let's see what happens if I've got x plus a squared. When I expand that, I get x squared plus ax plus ax plus a squared. And if I collect the middle terms together, I end up getting x squared plus 2ax plus a squared. Now if you look at it, so on the left hand side I've got the completed the square format, and I've got this term here a. That term always doubles, so doubles to give me the coefficient in front of x. Okay, and I'm always getting this, even though I started with 2 terms on the left hand side, I'm getting this extra term, which is a squared. So I'm getting 3 terms on the right hand side. Okay, now if I want to go backwards, so if I start off with something that's in expanded form already, so if I have x squared plus bx, I won't have a constant because a constant doesn't change much. So imagine the constant is 0. So x squared plus bx, and I want to put in completing the square form, which means I've got x plus something in the bracket and a squared there. Then if I look at this, I've doubled to get the coefficient of x. So if I'm going backwards, I need to divide by 2. So I've got b here. So if I'm going backwards, the coefficient of x will need to divide by 2. So which means b divided by 2 is the same thing as b over 2. Now because it's a positive b, it must be a positive b over 2 there. So here I've divided by 2 to get this number inside the square, inside the bracket. Okay, now is that all there is to it? Let's see what happens if I expand the bracket on the right hand side. So if I've got x plus b over 2 squared, if I expand that, I get x squared plus b over 2x plus b over 2x plus I get this other term, which is b over 2 times b over 2, which is the same thing as b over 2 squared. I'm going to leave it like that because it makes it easier to understand when it's like that. Now if the middle terms, if they're simplified, I do get x squared plus bx plus b over 2 all squared. Now if you look at that, I'm getting, if I look at the left hand side of what I started off with, I'm getting this extra term that I didn't want when I expand that bracket, which means I need to take off b over 2 all squared. So if I start off with the expanded form of a quadratic equation, then I need to halve the coefficient of x to get my thing inside the bracket with the square, and then I need to take away the square of this, take away the square of this. So that is how the method that you use to complete the square. So I'll try to do this with a few examples because it's much clearer with examples. So first example, Okay, if I want to write it in completing the square format, okay, there's an x always here. We've got -4 there, so I need to half it, which gives me -2. But remember, when I expand this, I'm going to get an extra square term. So I need to take away this square term, which is -2 squared, and then plus the 10, because I've got 10 here as well that I need to think about. Okay, if I simplify it, I get x minus 2 squared. Take away -2 squared is 4, plus 10, which gives me x minus 2 squared plus 6. And that's in completing the square format, because I've got a square number plus something. Okay, here, in the second example, I've got 9 here. I don't like that 9. So I'm going to factorize it out. So only factorize it out with the first two terms. Okay, so if I factorize it out, I get 9 times x squared plus 3 over 9x plus 1. Okay, I don't like the 3 over 9, so I'm going to simplify that to 9 times x squared plus a third x, okay, plus 1. Okay, now everything inside the square bracket I need to complete the square on. Okay, so 9 times, so I'm going to get something squared, take off something, yeah, plus the 1. Okay, I need to half the third. If I half the third, it's the same thing as doubling the bottom, so I get plus a sixth, okay? So a sixth, because half of a third is a sixth. Okay, and I need to take away this a sixth squared, because I need to take off this extra term that I'm going to get. Okay, if I expand this, I get x plus a sixth squared, take away 1 over 36, plus 1. Multiply each part out, so I get 9 times x plus 1 over 6 squared, take away 9 over 36 plus 1. 9 over 36, 9 times x plus 1 over 6 squared. 9 over 36 cancels down to a quarter plus 1. Minus a quarter plus 1 is 3/4, so I end up getting 9 times x plus a 6 squared plus 3/4. Okay, if I look at the next example, I'm going to rewrite this example as -2x squared plus 6x plus 13. So always have the x squared term first, then the x term, then the constant. Again, I'm going to factorize out the -2. So when I factorize out the -2, I get x squared, take away 3x, plus the 13. Always keep the constant term at the end on its own. Don't do anything with it. Okay, now I need to complete the square. So x squared, take away something, plus the 13. So I need to half the -3. So I get -3 over 2 squared. And I need to take away the square of that. Okay, so now if I expand it out and simplify, so I get x minus 3 over 2 squared. That I get take away 9 over 4. Minus 3 squared is 9. 2 squared is 4 plus 13. If I expand it out, I get -2 times x minus 3 over 2 squared. -2 times -9 over 4 gives me positive 18 over 4, which is 9 over 2 plus 13. Okay, if I simplify the last two terms, it's the same thing as 4.5 plus 13, which is 17.5. I prefer writing 17.5 as a fraction, which is 35 over 2. Okay, so that would be in completing the square format. Why does completing the square give you the vertex? Okay, so completing the square means I get it into this form. Y is equal to a times x plus p squared plus q. Okay, now square numbers are when you take a number and you multiply by itself. So if you multiply positive numbers, you're going to get a positive number. If you multiply negative numbers, you get a positive number. And if you multiply 0 by itself, you're going to get 0. So you're always going to get square numbers are always going to be greater than or equal to 0. So they're never negative. So they're always 0 or positive. So the least value occurs. So the least value occurs when this square number is equal to 0. So when x plus p is equal to 0, which means x must be equal to minus p. So at x equals minus p, you get the vertex, yeah? But when x is equal to minus p, your y value will be a times minus p plus p squared plus q. But that is just 0. So you get y is equal to q. So that means the vertex is at minus p, q. So once you've got it in completely the square format, your vertex is at this point minus pq. Okay, let's go through an example of sketching with the vertex also labeled. Okay, so as usual, a is equal to, do what we did in the last video, a is equal to 16, b is equal to negative 8, and c is equal to negative 5. Okay, so shape, a is greater than 0, so it's going to be a positive shape. Okay, y-intercept is 0 minus 5. Okay, x-intercept you can find using either, by solving it, you can either use factorization, completing the square, or the quadratic formula. Now, because we're going to find the vertex anyway, let's use complete the square to find the x-intercept after we find the vertex. So to find the vertex, let's do the vertex part here. We've got 16x squared take away 8x take away 5. So we need to complete the square. So again, the first two terms, let's factorize it. 16 times x squared minus 8 over 16x take away 5. Okay, because it's 8 over 16 can be simplified, I'll do 16 times x squared take away a half x take away 5. Now complete the square, so we're going to get it in the form, going to complete the square form. So minus a half, when you half it, you get minus a quarter. You take off the square of that, so take off the square of that. Okay, now minus a quarter squared, we can simplify that. So we've got x minus a quarter squared, take away 1 over 16 minus 5. Expand the bracket, we get 16 times x minus a quarter squared minus 1, because minus 1 over 16 times 16 is minus 1, take away 5, which means we get 16 times x minus a quarter squared, take away 6. Okay, which means the vertex is at a quarter minus 6. Okay, now we've got in complete the square format. If I want to find the x-intercept, I just need to equate it to 0 and solve it. So let's, because we've got it already in complete the square format, 16 times x minus a quarter squared take away 6 is equal to 0. Okay, let's rearrange it. So I get 16 times x minus a quarter squared is equal to 6, which means x minus a quarter squared is equal to 6 over 16, which simplifies to, okay, let's leave it as it is, 6 over 16 actually, so let's leave it as it is. If I rearrange it, I get x minus a quarter is equal to, when we take square roots, don't forget to include the plus or minus, so I get plus or minus 6, root of 6 over 16. Let's simplify now. So it's the same thing as plus or minus root 6 over, because root 16 is 4, I can simplify it to 4, which means x must be equal to a quarter plus or minus root 6 over 4. If you run to write it, so you get two solutions, so let's just write out the two solutions. I get x is equal to 1 plus root 6 over 4, which is going to be greater than 0 because all my numbers in the numerator are greater than 0, and adding together. And my second solution is going to be x is equal to 1 minus root 6 over 4, which is less than 0. Now that I've got all my information in front of me that I need, I can just sketch my quadratic. So I have a negative y-intercept. So negative y-intercept, I have a positive and a negative root. And also I have a vertex that is quarter minus 6, so it's going to be somewhere here. So a shape like that will be enough, as long as you label it right. So this point is 0 minus 5. The vertex is quarter minus 6. This one is a larger value, which is 1 plus root 6 over 4, which is greater than 0 anyway. And this one, 0, don't forget 0. And this one must be 1 minus root 6 over 4, 0. So that would be all labelled correctly. Okay, the last thing is trying to prove why the quadratic formula using completing the square. Okay, so you've got y is equal to ax squared plus bx plus c. Okay, the first thing, as we always do in the examples, is we factorize the first two. So if I factorize the first two, I get y is equal to a times x squared plus b over ax plus c. Okay, now I need to complete the square. So if I complete the square, I'm going to get x, because of the plus there, I'm going to get plus something squared, take off something, plus the c. Okay, half of b over a is b over 2a. Okay, and I need to take off the square of that, so b over 2a squared. So that I have completed the square. Let's simplify what we can now. So y must be equal to a times x plus b over 2a squared, can stay as it is. When we do b over 2a squared, we get b squared over 4a squared. Plus c. And don't forget the square bracket there. Okay, now next we expand it out, so I get a times x plus b over 2a squared. B squared over 4a squared times a will give me b squared over 4a plus c. Okay, now remember when we're trying to solve this, we're making it equal to 0. So let y be equal to 0, which implies we have a times x plus b over 2a squared minus b squared over 4a plus c must be equal to 0. Okay, let's take these two terms, the last two terms, over to the other side. So I'd get a times x plus b over 2a squared is equal to b squared over 4a take away c. Okay, let's try to write the right hand side over a common denominator. So I get a times x plus b over 2a squared is equal to b squared here. It's over 1. If I times by 4a at the top and times by 4a at the bottom, I get the same denominator. So I get b squared minus 4ac over 4a. Okay, now get rid of the a on the left hand side by dividing by a. So I get x plus b over 2a squared. So I'm dividing by a, which means I'm multiplying the bottom by a. So I get all over 4a squared. Okay, next top is, because remember we're trying to make x the subject of the formula, we take square root on both sides. But when we take a square root, don't forget to include plus or minus. So it's plus or minus b squared minus 4ac all over 4a squared. Now, because it's a square root with a fraction, we can square root the top and square root the bottom separately. So I'm going to have to travel here. X plus b over 2a must be equal to plus or minus square root of b squared minus 4ac all over, the square root of 4a squared is just 2a, so all over 2a. Okay, now I need to rearrange by getting rid of the positive b over 2a, so it becomes negative b over 2a, plus or minus, I can put right at the front, b squared minus 4ac all over 2a. Because the denominator is the same, I can write it on top of 2a, so I get minus b plus or minus square root of b squared minus 4ac all over 2a, which is obviously the quadratic formula. So that is how you derive the quadratic formula using completing the square on the general form of a quadratic equation.